Hey guys, so in this second video we are going to talk about how to make a microservice. In the last video we tried to define what it is, and now let's talk about how to make them. So we have these four projects which are in theory microservices. Now basically the idea is that usually you have some type of like a web interface or something like that. So that's one service. This is the service that we use to actually serve up something to a browser. And if you had other clients such as an Android project or something like that, that would be in a a separate thing as well. So you basically have your own code base for the client part of the system, right? You don't always have to have this, of course. You can have a completely data-driven API or something like that. And then we have one module for handling videos, one for handling searching, and one for handling books. So let's look at the books one. Now, books and videos are basically copy-pastes of each other, so we'll just talk about books, and we will talk about search, because search is a little bit of a different topic. So, this is what I like to call these books and videos and these type of very natural domain-driven terms, which are very closely tied to different like entities within your system. Is like I like to think of them as domain services that handle a very specific data structure or data type in your system. And then you have something like search, which is an aggregator or a consumer that just talks to other services to provide some type of value. So here is our server. Basically, it's just an Express server. So we import our app, and then we have the database URI so that we can connect to Mongoose and spin up the whole thing. Let's look at that database URI. This is something that is pretty. This is what immediately where some complexity is introduced to our system, because the thing is, when you put your code in a microservice or a Docker container more specifically, whenever you do that, you will find that you get connection issues, and you get you can't not make assumptions anymore about where things are on the network. What's beautiful about running something just locally on your own computer is that you can always go to localhost and to a specific port, because you're just running on your host machine. But in a container, you're not guaranteed what the localhost is just a host name for this IP address. That's what it is. But when you have a container, that IP address may change. Now, luckily, we'll talk about how the good people at Docker has actually solved this. But I just want you to be aware of that. It's a little bit trickier than just spinning something up on your local machine. So what I usually do is that I do this. I have a default, like this is basically how, if I didn't use containers or anything like this, and I didn't intend for this service to run in a container, I would just hard code this value for my local environment. But since we sometimes are in, just running the server locally on my computer, and sometimes it's inside of a container, I like to do this. I do a check for the URI in the environment, and I check if there is a specified URI to the database, and if there is one, then I'll grab that instead. So now, if all I have to make sure that I'm doing is that when I start my container, if I want the URI to point to some other address, I'll just have to input that inside of my container. So that's a small tip from me to you. Let's just walk through let's just actually look at the application itself. So here we have a dirt simple application. It's just an Express application. It has a model called book, and that's a very simple Mongoose model, which all it really does, it defines a schema that has a name and a default value of type book, and then it has a created at date that is default generated. It's dirt simple data structure. And basically we import that data structure, we instantiate our application, we use the body parser middleware so that we can post JSON to our Express server. Then we have the root endpoint just return the name of the service, and from experience I can say that this is very nice to just have the root of your API to just communicate, okay, this is me, I'm this service. You might want to do something even more fancy than this to like give the, usually when you have a lot of services, maybe you have several versions of the same books microservice, you might want to have some type of unique IDs that is coming back when you're hitting something, so you can kind of debug things and know which service you're talking to. I like that a lot. And then we have these two endpoints, so we can get a book, and basically all it does is that you do a request to API version 1 books, and then you await on and do a book.find, and then you return all the results from the database. And you can also post a book, so we do a request.body.name, and then we instantiate a book, we save it, and then we return the saved book. Dirt simple. And this is exactly how the videos section work as well, so we don't have to walk through that code. In essence, it's just the word books is changed to videos. Let's look at the Docker file. This is where we start thinking about how to put this into a container. Now, a Docker file is a file that you use in order to specify how Docker is supposed to package your application. And this is fairly important, so let's walk through it. So first and foremost, we declare where we're going to get our base containers. So because our code needs to use Node, we want to have a base container that has Node. I mean, you can make something much fancier than this. You can have all kinds of base containers. So you can have Ubuntu or Windows. Well, not Windows. Maybe they can do Windows today, but say Ubuntu, for example, or Linux boxes where you can build up anything you want. I mean, you don't just have to have Node in the thing. You can put anything in your container. You can have PHP, Node, Java. You can have anything you want. Basically, it's just that since we only need Node, it's very nice to have this pre-prepped Node environment that we can depend on and build our application from. And then we do a copy, and this dot here means basically that look at the current directory and copy everything in that current directory to the source, which means that if I want to do Docker build, or I want to build this container, I have to be inside of this directory. That's it. And then I specify the work directory, which basically means that if I start up my this container and I basically jump into the container, I'm going to be put into the source directory, and all the commands that I run that I declared down here are going to be run inside of this source. And this is, I hope this makes sense, that since we copy this entire project into the container's source directory, we want all the commands to run inside of there as well. So after the container is been, when it's been created, we start by running npm install -- production, so that we install all of the Node modules and we instantiate everything correctly. Then we expose 3000, which basically means that this container needs to open up a port, because as we saw in my server here, it's actually running on port 3000, which means that, which means that we want to expose that port so that other containers can communicate with this container on that port. Nothing else is, basically that's the idea, so that we can actually reach inside and talk to the application that's running inside of the container. Then we have npm a command that's called npm start, and basically this is there to basically when you start the container, when you saw in my previous video where I did docker run, what happens is that this is just a way for me to specify what command to run in the container when I start it up, so I don't have to specify that myself every time I want to start it. And this is fairly common practice. So this is just think of it as a blueprint for how I want my container to be built, and what files I want to be there, and basically how I want everything to be set up for me. So that's how I create the container. Now, let's look at another example of a microservice, because what I want you to take away from this is that a Docker container is not a microservice. A microservice is just this mental idea that you can take big applications and slice them up into really, really tiny pieces. Now let's look at search, because search is pretty much the exact same thing as books and videos, with one major difference. Let's look at the models here. So in books, we only have the book model, and in videos we only have the video model, but here we have both, and these are, as you can expect, intended to be the same models. Now, why have we copy pasted in this? I'll show you. So let's look at search. So search has the fetch API. Basically, we import fetch, and then we use express just as anything else. And here is a little comment about why we're doing this. So notice that we are that we have duplicated our models from the other services. This is bad. You should extract the common code into an npm module that you can then import into your project just like any other package. The reason why I'm not doing this is because it's a little bit tedious for for our demo. But the thing is that search, if you think about it, search does not require its own database. It doesn't require its own model. In like a very basic example, doesn't need it. But what you do need is to know how to basically get data from the database. You need to be able to, you need to know what the other services that you want to be able to search for. You need to have some type of connection. Now, this is a very simple way of doing this. You can do much more advanced things with searching. I just wanted to illustrate this idea that I think it's very useful if you have common code. If everything's running on Node or something like that, and you have things that need to be shared between different modules or different microservices, put them in an npm package like any other library, like a Node, Fetch, or Express, and just put them in there and then import them into your project. It makes it very easy for you to move common code amongst your projects. You don't have to copy, paste, and duplicate, because this is very dangerous. Let's say that I change the books module in my books microservice. Well, then I have to make sure that I'm changing it here as well, and that's not so nice. It's much nicer to share that as a common library. At least I think so. Then we have the root, as we saw it earlier, and then we do API dash version 1 search, and let's just talk about that pattern because you saw it earlier as well. Personally, what I really like when you have an API that you do dash API dash and a version flag. And the reason why I think this is so useful is because, especially in microservices, when you may have like really large systems and you have all these different systems that are talking to each other and they depend on each other, it's very nice to have a way of versioning your different endpoints. Because let's imagine that you created this endpoint and then you have like 100 different services using this endpoint to do searching. Well, what happens if your boss comes in and says, hey, we need to add some new feature that is going to be a little bit different on the search endpoint? Well, what's beautiful about this is that now I can copy paste this endpoint, create another controller method down here and put it to version 2 instead, and I could still, and then that makes me backwards compatible, so that the APIs that need version 2, or the services that you need version 2, they can talk to version 2, and the ones that are still using version 1 can stay on version 1 until they roll over to version 2, or they can stay there as long as we support it, right? So I think that's a very elegant little thing to do. I think it's a very good practice in general to have when you're creating APIs. So let's walk through this code here. So when we're searching, we do the silliest, dumbest search in the world. All we're really doing is that we're getting all the videos, all the books, and then we I'll just walk you through this as well. So you may ask, why are you not awaiting on these two? Well, the reason why I don't want to await is because I want to get both of these results as quickly as possible. And if I put a wait on video and then on book, it's going to run synchronously. Basically, it's going to first get video and then it's going to go and get get the videos, and then it's going to get the books. I don't want that. I want it to happen simultaneously. So I get the promises for both of these two calls to the database, put them in an array, and then I do promise.all and await those promises, and then I destructure the resulting videos and books arrays, and then simply concatenate the response so that all the books and all the videos are in the same array results. That's just something I like to do when I have multiple AJAX calls going out at the same time, and I really just want them all to come back. I don't want to wait for one and then do the next and then the next. I just want everything to happen as quickly as possible. So this is the basics of search. So search is this, think of it as a data aggregator between two other services or multiple services, and it's called a so-called, in my opinion, it's called a so-called cross-cutting service that talks to different other services in order to provide some type of value. It doesn't have its own data necessarily. Now, this is where most times when I've seen people do microservices wrong and the stories I've been told about how big companies have done this incorrectly, this is where it gets dangerous. Because it's very easy to do microservices work if there's just a single connection. You know what I mean? If I just talk to books and books never talks to anybody else, it just talks to the database, and then it returns the data. It never has to go to any other service to get its information. That's very safe. It's a back and forth communication, but it gets very dangerous when it comes to searching, because searching, like, this is not so dangerous because we're talking directly to the database, but you don't necessarily want this. Maybe you wanted something else. Maybe you wanted to do something like this, where you might want to do something that is a little bit contrived, I'm going to be honest with you, where we basically we do a call and we want to check what dependencies do we have here in search. Basically what we're doing is that we want to know what dependencies we have, like what services are search talking to. That's it. And depending on if maybe we wanted to know, what the dependencies of our dependencies are, we start to get into a little bit of a danger, because what can happen, we'll look at these comments here, what can happen is that, let's say that you are calling one service, and then that service is calling a third service, and then maybe that service is calling yet another service, and then the chain just keeps on going and going. The most dangerous thing that can happen is that you have a chain of services talking to each other in such a way that you create a circular dependency. What if one in our chain, all of a sudden we find that one of those services that are needed in order to answer this first call actually talks to our own service, so the whole thing starts looping. It becomes an endless loop where everybody's just trying to talk to the next service, and that service is talking to the next service, and so forth and so forth. And it's very dangerous and it's very easy to get into this problem when you have a lot of services, because you don't know how, it's very difficult to have an understanding of how everything is connected. That's one of the biggest drawbacks with microservice. Orchestration is absolutely key. And another thing that's very dangerous is that for every time a microservice needs to do another network request, this time it takes to get the first request back takes longer and longer. I was told a horror story where a really big company had gotten this wrong, and they took down their load time of their main product page on release day to 9 minutes. 9 minutes for loading their web page because they did this wrong. Now let me talk you through how I think, or rather the solutions that I've seen to dealing with this problem. So cross-cutting services should, if you have them, abide by the one-hop rule, which is, this is not an official term or anything like that. I've heard it thrown around a few times. That's one way of doing it. The other way is that you use a message queue for all service-to-service communication. Basically, no service is directly talking to another service. They're talking to a message queue such as Kafka, RabbitMQ, or ActiveMQ, or something like that. And then basically they could handle all of their dialogues that way, because then you only have to talk to one service, and it becomes very easy. Like, you don't get this delay problem that you have. There are other problems that you have to deal with, but it's a much safer bet. The one hop rule, which is what we're going to look at here, is that if the rule should be is that a service can never start a call chain that is longer than one. Basically, if we look at our dependency, or the call chain that we have from search here, so our search service is going to talk to books or videos, or both of them basically. And that's safe for us, because books and videos are the end of the chain. They are not making any more calls. But if they had, we would have to deal with this somehow. We would have to maybe store data in some way so they didn't have to go and make more calls, because what we don't want is something like this to happen. That's the danger. What happens if search talks to books and videos, and in order for them to answer search, they need to talk to search, and then it just spirals and everything goes to absolute shit. So that's something you have to be very, very mindful. That's why microservices gets very, very tricky at a large scale. So here we have another example of how we're going to run these queries. So we're basically, this time we're not talking to the database, we're actually making a network request to these different hosts. So let's, I think I mentioned this earlier, but basically when this domain name basically is going to be resolved when we're running this in a container. Like, I haven't done any environmental checking here, so you have to just bear with me. This container won't actually work if I just, like, you know, if I don't run these things properly, it's going to break. But just bear with me. Search is it's just me being lazy. In a perfect world, I would make sure that I checked if I was in a container or if I was just on my local machine, so I could do local development on search. But this is for demo purposes, so this will only work inside of a container. So I go and get the video. I get the videos, the response from video, and I get the book response basically, or rather the promises, put them in an array. I do a promise.all, resolve both of them at the same time or as quickly as possible. I get the JSON response and then I send it back to the client. That's basically it. So these are, now I've walked you through the basics of or rather the two basic types of microservices. Basically, you have domain entities or domain services that are responsible for dealing with a certain data type or something like that, and then usually you have all these cross-cutting services that provide some type of value. It can be search, it can be statistics, logging, password validation. There can be all kinds of services. But I think this is good enough and a good stopping point for us, because hopefully it has illustrated for you how a microservice is orchestrated and what the basic idea about them are. And finally, in the next video, we are going to talk about how to actually make all these microservices, how we make them talk to each other. Because as you may notice, we'll look at my client-side code here, the interface that we're going to use, this web page that we saw earlier, where you have a section for creating books, which is just a form, and then you have a section for videos and one for searching, and we have all this code here. We're going to walk through all of that in just a moment in the next video. But basically, we can't have every single server, like when you're shipping code to the client, we can't specify port numbers that are, all the different port numbers. It would be very troublesome for us to have to know where all the IP addresses and all the port numbers for every service. So we need a way of dealing with that. And that's where Nginx comes into play, where basically we have a reverse proxy system in front of everything that is going to channel through all of the different requests that we have to the correct service. That's where we get to orchestration. So let's look at our processes here. Yeah, so all our microservices are running. And what's powerful about this is that I can go to localhost 3000. This is where our web application is running. If I go to localhost 1, that's where our search is. Localhost 2 is where our books are running. And finally, videos is where the video section microservice is running. And if I go to 8080, this is where Nginx is running. We see the same page as we saw for the web interface. And that's exactly what we're going to talk about in the next video, how a system such as Nginx can help us abstract away the need for the user of our system to know where everything is.